Welcome to the experimental video for Experiment 2. The initial step in this experiment is to weigh your reagent masses as you have calculated before you come to the lab. As an example, we will do this for potassium iodide. Roughly 4.15 grams of potassium iodide needs to be weighed. We will do this in a small beaker. Initially, we will tare the scale by placing the appropriate beaker mass on the scale and then pressing the tare button on the scale. Thereafter, remove the beaker from your scale and then start transferring potassium iodide or your appropriate reagent to the beaker. Initially estimate the mass required, and then you will place the beaker back in the scale to see how much mass you have transferred. As you can see in the example, we are still off from the initial 4.15 grams that we require. We will now slowly move towards 4.15 grams, as you will see Joel do in this video. Of course, as you start to move closer to the actual mass that you would like to weigh, you will need to start using smaller and smaller amounts of your reagent. Be careful not to overshoot by too much, since we will be using the weigh by difference method, and you will need to discard any additional mass in the waste beaker provided, shown after we've weighed, so not to add too much reagent. Notice the technique Joel uses to transfer only a small amount of potassium iodide to the beaker. He scoops up a bit on the spatula and gently taps on the spatula to transfer only a small amount. As you can see, we slightly overshot our end mark of 4.15 grams. So we take out a little bit. We are still slightly above the mark, 4.18 grams. And we remove a little bit more until we get to the desired 4.15 grams. This is close enough, and we are quite happy with this amount. Now, all the excess transfer to the waste beaker provided. This will be the same beaker you will use. Put that in there and record your final mass that you have collected. Now, in the next step, you are going to zero your scale and you're going to record the mass of the beaker plus the weight of your sample, because we are going to use a technique called weighing by difference, as this will make sense in a moment. So record the mass of the beaker plus your sample, as Joel indicates in the video. Now, using a funnel, put the funnel on your and then transfer your potassium iodide to this funnel, ensuring that you transfer as much from the beaker to the funnel as you possibly can. Hereafter, you're going to weigh the beaker again and calculate the difference between the mass of the beaker before you've transferred the potassium iodide and now after you've transferred all the potassium iodide that you possibly could. And this difference will give you the actual mass that you've transferred to your volumetric flask. As you see, Joel writes down now the mass of the beaker without the sample. And the difference between these two masses is then, as I said, the mass that is actually being transferred, the actual mass of potassium iodide. A quick calculation will show that we actually lost about 0.01 grams during the transfer process, and hence we are now in the 4.15 gram range for potassium iodide, which is as required. Absolutely perfect, if I might add myself. In the next step, you will transfer your potassium iodide or your appropriate salt from the funnel to the volumetric flask using distilled water. Rinse the funnel using a distilled water bottle as indicated in the video. Thoroughly rinse the funnel to ensure that you transfer all the salt into the volumetric flask. Then, dissolve the salt first while the volumetric flask is not yet completely filled. This will allow you to first homogenize the solution at the bottom before filling the volumetric flask to the line indicating an exact dispensed amount. If you dispense the amount to the line beforehand, you will have trouble dissolving the salt. Then add more distilled water to an appropriate level just below the mark indicated on the volumetric flask, which indicates the appropriate volume of this flask. Here we are working with a 250 milliliter flask for the potassium iodide solution. Once you've reached an appropriate level of water, as you will soon see, just below the mark indicated on the volumetric flask, you will turn to a dropper pipette, a plastic pastilles pipette, to reach the appropriate level. As you can see, there is some water droplets still left in the stem of this volumetric flask. And so we will stop with the meniscus slightly below this line to allow, once we've shaken the volumetric flask again, for those droplets to be incorporated in the volume or incorporated in the total volume of this volumetric flask, and then to ensure that we've accurately dispensed 250 milliliters. Of course, before you completely start stirring or homogenizing your solution, ensure that your volumetric flask is stoppered with a correctly sized stopper. To homogenize, simply tilt and twist to ensure that you capture all the little droplets that was left in the stem of the flask. Thereafter, always ensure that you mark your glassware with an appropriate marker. Our next step is to prepare the starch solution. So take your 1 gram of starch, which you have made a paste with some cold water, and to this we're going to add 100 milliliters of boiling water, which you've collected from a kettle. To measure the 100 milliliters of boiling water, use a measuring cylinder to fill or to transfer the water from your beaker to the mark on the measuring cylinder. After you have transferred your 100 milliliters of boiling water or extremely hot water, be careful, to your paste, you will place this paste or this cloudy mercury solution back on the hot plate to be heated for a further 2 minutes until the starch has dissolved. After your starch solution has been left to boil, add another 100 milliliters of distilled water. This distilled water can be at room temperature. You will see the starch solution does not turn completely clear. Next, we need to dispense our different solutions to form reaction mixtures R1 through R5. To start, we will use the potassium iodide solution as an example. Take a funnel and place it on a Buret as illustrated in the video. Next, take your potassium iodide solution, ensure that it's still homogenized, and then simply add it on top. but do not add more than about 10 milliliters since you're going to use this to rinse your Buret first. The rinsing ensures that your Buret is cleaned with the solution that you're going to use the solution you will be using to dispense or dispensing with. First, start by dispensing out through the top part of the Buret. Turn the Buret horizontally, twist it by running the solution downwards and allowing some of the solution to run out at the top. Then turn it around, open the tap, and then shake the Buret to thrust out some of the solution at the bottom to ensure that the tap and the bottom part is also rinsed with the solution. You can repeat this process a few times with whatever solution you have left in your Buret after you've completed the first round. Thereafter, re-secure your Buret in its Buret stand. Of course, just ensure that you have all the solution that you've used for rinsing out of the Buret, and then secure the Buret in the Buret stand. Now again, use the funnel to add your potassium iodide or whichever solution you are working with in that Buret to it. In this step, you are allowed to slightly overshoot the 50 milliliter mark of the Buret, since you can easily play around with how much you need. Unfortunately, in our case, you can see there's an air bubble trapped at the bottom of the Buret. To release this air bubble, we first have to open the tap and thrust the Buret again to open or to thrust out this bubble. This will ensure that there's no air bubbles trapped in the Buret and that we will have an accurate measurement of the volume. As you can see, we have removed our air bubble. Always check for this before you start any dispensing process. Now, of course, this means we need to add more potassium iodide or whichever solution you are working with. So add a few milliliters again and add it until above the 50 milliliter mark so that you can dispense to an accurate 50 milliliters or to whichever milliliter starting point you would like to start at with your Buret. As you can see, we are slightly above 50 milliliter, and we will now dispense those few milliliters into a waste beaker so that we start at exactly 50 milliliter. And now we know when we start dispensing, we start from 50. Of course, in this experiment, we will not only have potassium iodide, but we will also have sodium persulfate in a Buret. We will also be using potassium nitrate solution. We also have our starch solution prepared earlier. We will also need distilled water. And then finally, our potassium persulfate solution. All of these solutions are prepared as per table 2.3. Now prepare reaction mixtures R1 through R5 in a beaker by using the Buret and dispensing your appropriate volumes accurately. Remember, the bottom of the meniscus needs to lie on top of the line indicated in the Buret for you to have an accurate dispensing of that specific volume. Here you can see we've dispensed 5 milliliters of potassium iodide solution accurately, since the bottom of the meniscus touches the 5 milliliter mark. For the potassium nitrate solution, you will be using a 10 milliliter pipette to accurately dispense 10 milliliters each time. To start off, remember to homogenize all your solutions before measuring. Transfer from your volumetric flask your solution to a beaker. Thereafter, you'll be using a plush bulb and a 10 milliliter pipette. The plush bulb is a red bulb with 3 regions: A for air, S for suck, and E for eject. We use it as follows. You will press in A to allow the plush bulb to drag a vacuum. After releasing A, it will create a vacuum, which will then be used to suck up anything through the pipette. Do not push the pipette in further than that line indicated by Mr. Lekitima in the video. Next, we will rinse the pipette as we do the same with the Buret. Press the S on the plush bulb to suck up some of the solution and then remove it while the pipette is slightly horizontal. Quickly cover it with your thumb to ensure there's a vacuum, and then rinse both sides of the pipette as shown in the video by tilting the pipette to either side, ensuring while turning the pipette in your hands to ensure that you have completely rinsed the pipette on all sides with your given solution. With the pipette, it's advised to do this twice since you might easily miss a specific spot on the pipette, and we're working with very small volumes on this, not as much as we worked with in the Buret. So do it for a second time, following the exact same procedure, working with a horizontal pipette, twisting it around in your hands, slightly tilting it to either side, first forwards and then backwards, allowing the solution to drip out of the pipette. Now we are ready to dispense our solution. Using again the plush bulb, place it on the pipette, no further than the line indicated on it, and pressing the S button for suck. You will suck up your solution up until the indicated mark on the pipette. I do apologize for the following part will be completely out of focus, but you might imagine for yourself there is a line, and our solution is somewhere close to that line. There you can slightly see that line. It's a brown line, a very small thin line, which I tried to get in focus. I tried my best, and that's all that counts. Once you have an accurate volume, you dispense it pressing the E button, eject, or completely removing the plush bulb. You add this to your beaker and your reaction mixture, whichever reaction mixture you are busy generating at this stage. Remember, once the end of the solution is being reached with the pipette, the last droplet won't necessarily be dropped out of the pipette. It will be kept in the pipette. Another type of pipetting device you might encounter in the lab is called a suction pump. This device works as follows. You will have a turning wheel to suck up, and you'll have a dispensing knob which you can push as that to dispense your solution after you have sucked it up. Step 5 requires us to dispense different amounts of potassium persulfate into a 100 milliliter conical flask as indicated in the video. You will again use a Buret for this purpose. Now that you have prepared your 5 reaction mixtures as well as your potassium persulfate solutions, have them line up and have a weight for each of these reaction vessels, as well as a stirrer for each of them. After placing your weighted reaction vessels in the water bath, you need to allow them to equilibrate for at least 10 minutes at an appropriate temperature. Note that even though it is specified that this temperature is around about 40 degrees Celsius, of course, in actuality, it is not exactly 40 degrees Celsius. That is why you need to take the precise temperature of the thermometer to be at around about, for example, 36 degrees Celsius on our day. You will, of course, do this for your appropriate lab day. Always ensure when you're touching a thermometer to take it on the plastic handle at the top, since the heat of your hand can disrupt its equilibrium. Now we need to add our potassium persulfate to each of our reaction mixtures. You need to do this quickly, though not too quickly, since you can monitor the times quite precisely. Once you've added the first mixture, start your timer to ensure that you have the initial time measurement for your first reaction mixture. Note down the time and then proceed to the next mixture. This will give you the initial starting times for each of your reaction mixtures. Thereafter, you will investigate or note down the times when the color change for your reaction mixture takes place. When you start seeing your first blue-purple color change. Continually keep on stirring your mixtures once you've added the potassium persulfate solution. This will ensure that you have a homogeneous solution throughout the reaction process and you'll have accurate data. You should see a color change quite quickly. As you see here, for our second reaction mixture, there's an initial change to a sort of brownish purple color, and thereafter the colors intensify quite deeply to a deep blue. This deep blue color, as you can see for most of them, they will change periodically at different times, which you note their different times at which they change, and of course the difference between their starting time and their final time is the time length or the length of the reaction. Once the final reaction mixture has changed color or started to change color, note down that final time and then you may proceed. You will proceed to do this for all three temperatures indicated in the practical manual: 25 degrees Celsius, 40 degrees Celsius, and 60 degrees Celsius, following the exact same procedure. Of course, the final step in any experimental procedure is to discard of any waste collected during that experiment. Look out for the experiment 2 waste and discard all your reaction waste in that container. Thank you for watching.